In this video, we'll be showing you how an engine works in thermochemistry terms. The engine is the system, and the car combined with the world around it is the surrounding.
An engine uses a combustion reaction. The reaction is shown here along with the enthalpy change during the reaction. The change in enthalpy is equal to the change in energy of the system plus pressure times the change in volume. Since this is an engine, the change in enthalpy will not be constant as the volume and the pressure will always be changing.
The chemical potential energy stored in the chemical bonds when the gas is let in the gas chamber increases the net internal energy of the system. The gas in the chamber undergoes a combustion reaction and is then ignited with a spark plug, converting that potential energy in the chemical bonds of the gas into kinetic energy. The kinetic energy is the movement of the particles that is then, when it bumps into the piston, is converted into work energy. The products of the reaction, H2O and CO2, are then pushed out through the exhaust pipe.
Liquid octane has a very low specific heat capacity. That means that it does not need a ton of heat to combust it, allowing the spark plug to be able to combust the gas efficiently. Materials with high heat capacity require a lot of heat to be stored up before a small change in temperature can be measured. Materials with low heat capacity require very little heat to be stored up before a large change in temperature can be measured. The SI unit for specific heat capacity is joules per Kelvin per mole.
Enthalpy of formation is the enthalpy change in the making of the product from its elements. The enthalpy of formation of the products H2O and CO2 is negative. The enthalpy change comes from the formation of the bonds and elements of these two compounds. The energy released in the reaction can also be measured in kilocalories, which is the energy needed to raise the temperature of 1 gram of water by 1 degree Celsius, now usually defined as 4.1868 joules.
The first law of thermodynamics is present in the combustion reaction because the energy released from the combustion is transformed into work on the piston, causing the piston to move because the reaction surroundings are a small enclosed space and the excess energy can only be transferred to the piston through work. In the gas chamber, the pressure increases exponentially when the gas is combusted because the H2O and CO2 are violently created and are with a lot of kinetic energy and are pushed out, converting into work being done on the engine, causing it to move.
In conclusion, thermochemistry is a big part of how an engine functions. First, the octane combusts into two other compounds, releasing energy and pressure. This energy is then transferred onto the piston and moves it. The amount of energy needed to ignite the octane is fairly low because of its low heat capacity. Hopefully, we have helped you understand thermochemistry and how it is involved in an engine.